All right, big picture. This is more notes to myself than notes for you at the top, so you wouldn't write this down. But this is me reminding myself that I will work number 1, and then you will work numbers 2 and 3 today. On Wednesday, not me, but Miss Craig will work number 4 and start number 6 with you, kind of get it launched, and then assign 5 through 8. So both days are kind of the same thing, although tomorrow is a little more calculator, maybe new buttons on the calculator you haven't done before. Today is with calculator, but I feel like a little bit easier with the calculator. Speaking of calculators, I'm going to press pause and you can go. Alright, so now you've got a calculator, again the 84 or the Inspire, either one. I'll always use the 84 because it's the one I'm used to, but it doesn't matter to me which one you use. Calculators allowed. We have to be careful though. You still need to show your work. And justify. Use that word a lot. So the calculator is there to help you, but you have to explain either what your calculator did, or how you used it, or the equation you put in. Like, I don't just want you to write 12, 7, negative 3, because then I don't know, like, well, where'd that come from? And I know you used your calculator, but you've got to give me some words or some explanation as to where those answers come from. So, yes, you get your calculator, just don't rely solely on your calculator. I need to know what's going on in your brain, not just what your calculator told you. Alright, so we'll draw the graphs on your paper, label the axes and important points. Important points, we should probably talk about what those are. Let's say those are the intercepts and the max or min. Intercepts and maxes or mins. Everything's a quadratic today, so it's either a up parabola or a down parabola. So the vertex is, which is another word for max or min, maybe I should have just said that. Vertex. And the vertex is the max or the min, depending on what the parabola looks like. So you know how to do those things without a calculator. You get your calculator to help you, but we still want to show, where those things come from. Show the equations you put in your calculator and how you determine the final answers. If one or more answer is not valid for the situation, you need to explain why. This is usually, if you get a time that's negative, it's usually like, wait a minute, that doesn't make sense. The ball hit the ground 3 seconds before it was launched. Like, what? That doesn't make sense. So, a lot of times we're throwing out negative times. All answers should be justified with graphs, equations, explanations. Round to the nearest thousandth when necessary. What decimal place is the thousandth? 3. Tenth, hundredths, thousandths. And 3 decimal places is kind of arbitrary. Like, is 2 accurate enough? Why not 4? Why not 6, for that matter? We pick 3 because that's what the AP test uses. And you're obviously maybe 1 year away if you do pre-cal next year, 2 years away for calculus the year after that. But it's arbitrary, so we may as well match what College Board does just so you get used to doing it. So pretty much any time in here, we'll do 3 decimal places just to kind of make that the normal. That way when you get to calculus, you'll just think 3 decimal places is the normal thing to do. Alright, David kicked the ball into the air. The function of the height of the ball is h equals 64t minus 16t squared, where t represents the time in seconds after the ball was kicked. Draw the graph of this function, label the axes and important points on the graph. Okay, so let's grab our calculator. Figure it out. Y equals, or however you get there on the Inspire, 64x minus 16x squared. The trick is going to be the window. I intentionally changed mine to a bad window because it was already fixed because I used it last period. So there's my parabola, but that doesn't really help me looking at that thing. So you need to go to the window and change what the window looks like. So window, my X didn't look too bad, but I don't need to go all the way to -10. And it looked like +10 was pretty far out there as well. The main thing was I needed a bigger Y max. You need to look up higher. So I don't know how high. I'm just kind of playing around and checking. So I try 50 and not enough. My X's are good. Like, I'm fine with those X's. I could narrow it a little bit, but it's close enough. But I need to see up higher. So maybe 70, 75, 100. I don't know. As long as you can see the max, we're good. So the window is kind of guess and check, play around until it works. There is a zoom fit. If you go to zoom and zoom fit, it will fit the graph on there, but it's not usually the fit that you want. So you can do it, but that shows me a lot more, because I don't care about the negative stuff. Like, this is a ball that's kicked into the air. I don't care what happened, before the ball was kicked or after it hits the ground. So zoom fit, if you need it, I guess it's fine. Just be careful, because it gives you more than you need. So back to my window. I know I don't need to see the negative stuff, so I'm just looking at the positive stuff. Okay, now I want to put that on a graph of my own. Okay, some key points. The vertex would be a key point. What's the x-coordinate of the vertex? Jacob? Well, what's the formula for the x-coordinate of the vertex? You remember that? -b/2a. This one's maybe tricky because we got b and a sort of backwards, but so -64 over 2 times -16. So that would be 2 comma something. For a nice even point like that, I might go to the table and hope that it's there. 2 comma 64. So there's my vertex. I don't have to draw the axis of symmetry, but it might help. It might help me remember that the thing is symmetric, which means if I can find one of the x-intercepts, I can kind of mirror it and find the other one. Let's see. X-intercepts would be where y equals 0, or height equals 0. Now you can kind of tell by looking that one of them's at 0, 0. And that makes sense. If I factor out 16t, I get t equals 0 and t equals 4. There's my other one. 4, 0. Okay, so I'm using my calculator, but I'm also using my algebra and justifying, showing what this stuff is, what it means. Alright, part A. Draw the graph of this function. Check. Label the axes. Whoops, haven't done that yet. What is the x-axis? What is that measuring? What's the independent variable in my equation? Time. So this is time in seconds. This is the x-axis. What about my y-axis, my dependent axis? What depends on time? Height. And that's measured in, feet. Okay, so now I've got, draw the graph, label the axes, important points, we got those, the vertex and the intercepts. Okay, now we can start answering questions here. How long was the ball in the air? 4 seconds. I like that answer. How would you justify that, or how did you know it was 4 seconds? What did you plug into an equation? Noah, what would you say?
4 seconds is double the number of the vertex. That's the x coordinate of the vertex.
4 is not the x coordinate of the vertex.
Double.
It's double. Double won't always work though. That only works if you start at the origin. So you're on the right path. I think you guys are making this harder than it looks. That was when h is 0. When h is 0, we were back at the ground, and the ball was no longer in the air. How about the maximum height of the ball? 64 feet. I like that. But how did you know that? Like, where did you look? I mean, obviously you looked. Oh, it's right there. But use a mathy word to say what that is. Let's be more specific. The y coordinate of the vertex. Y coordinate of the vertex. When did the ball reach maximum height? So that would be t equals 2 seconds. I bet you're getting the hang of this. How did you know it was 2 seconds? What were you looking at? The x coordinate of the vertex. How high was the ball after 1 second? That one I don't know by looking at the graph yet. So what will I have to do? Let's just plug in 1. So h of 1, right? I mean, there's 1 second. I can see sort of where it is, but that's not good enough. I need h of 1. So let's plug in 1. You've got a calculator. You've got a table on the calculator. So you can just tell me what h of 1 is from the calculator. You don't have to plug in 1 when the calculator's already plugged in 1. So h of 1 is 48. H of 2.5. It's wait, that's not on my table. So how am I going to find h of 2.5? Well, I've got options. I can just go back to this main screen and plug in 2.5. In fact, that's the last thing I did apparently on this calculator, was plug in 2.5. So apparently it's 60. But I want to show you a trick. Second calc value. I don't know how this works on the Inspire, but the 84 from the graph, if you do second calc, you get some options that are pretty cool. Value, zeros, mins, maxes, intersections. Let's pick value because I want to know the value of the function. And then it prompts you, x equals what? What would you like x to be? Well, I would like 2.5. Thank you very much. And it tells me that y is 60 at 2.5. So you've got the table. You can just plug it in yourself. You can use second calc value. You've got options for h of 2.5. Jacob? What's that? Yes, Inspire, it has it. I just don't know where it is. H of 5. Again, you can plug it in if you want. I bet that one's on the table, though. So just second table for the 84. And there's h of 5 is... Wait, h of 5 is negative 80. What does that mean in terms of my graph? Yeah, it's wait a minute. Something's not right here. It's already hit the ground. So I don't really know that h of 5 is really negative 80. It didn't go into the earth here. How high was the ball when it was kicked? How high was the ball when it was kicked? 0. How did you know that? Okay. Started at origin. I'll take that. When it was kicked, that would be t equals 0. So it won't always start at the origin, so we have to be careful about that one. This one did, so that means it was a 0, but more generally, its starting spot is h of 0. Jacob? What's that? Okay. When was the ball 45 feet high? Show your work algebraically, then round the answer to the nearest thousandth. So, what am I going to do with 45? Like, I don't want to answer that. Think of, like, what do I do with 45? Where does that go? That's h. So, 45 equals 64t minus 16t squared. I'm going to move the 16t squared over to make it positive. Minus 64t plus 45 equals 0. Now, I've worked the problem before, so I know if it factors or not. But if I didn't know, and the first time I worked it, I was like, even if that factors, I don't want to sit here and try to figure that out. Because my factors of 16, 1, 2, 4, 8, 16. My factors of 45, 1, 3, 5, 9, 15. Like, that's a whole bunch of combinations to hope to land at 64. I don't think that's a good plan. So even if it would factor, I think I look at that and be like, no, I've got a calculator. So what method should I use instead? Let's use the quadratic formula. Like, the numbers are big and ugly, but who cares? We've got a calculator. T equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right. Rather than jamming that thing into the calculator all at once, which might or might not work, especially since there's no plus or minus button. People always want to look for that. You have to do them separately. But before we do that, let's find the discriminant first. Find discriminant first. Because that will, what does that tell me? You tell me. What does the discriminant tell me? Right, if I have real solutions or not. So let's find that number first. That will simplify what I put in my calculator, and I'll know like what kind of answers I'm headed for here. 64 squared minus 4 times 16 times 45. So 1216. So that's 2 real answers. I don't know what those answers are, but 2 real answers. And this question didn't ask for it, but in the future we'll ask for an exact answer. That's an exact answer. We haven't rounded anything. We're going to go to our calculator and round it in a minute, but that won't be exact. Right? Just because you write down what your calculator told you doesn't mean it's exact. If you rounded it, it's not exact. So let's do 64 plus square root 1216 over 32. And 64 minus square root 1216 over 32. I like to use the fraction bar. Whoops, that's not the fraction bar. That's the fraction bar. Alpha F1. You don't have to. You can put parentheses. Just be careful with parentheses and the square roots and division. Again, fraction bar is alpha F1. If you like that, it keeps it straight as to who's in the top and who's in the bottom. So I do the plus 1, and I get 3 point. 0.090, because it asks for 3 decimal places. But that's not an exact answer, right? Even if I wrote down all of those decimals, that would not be an exact answer because it's rounded. So that's a rounded answer, and that's fine. Just be careful when it asks for an exact answer, you might leave a square root in there. All right, for the minus sign, let's just change the plus to a minus. 0.910 seconds. Okay, now I want to show you another way that your calculator can do this. Because we wanted to know where that equation was equal to 45. So I'm just going to go ahead and graph 45 as well. That way I get a picture of this point and this point. And so I could trace and I could get kind of close to it. And so that's not perfectly it. Like my calculator is at 0.89 seconds and I'm at 44 meters or feet. So that's close, and that's close to matching. So that's a little bit of a check. In the neighborhood check. Come on the other side and do that same kind of thing. The closest I can get is 44.4. That's at 3.1 as opposed to 3.09. So I feel like my answers are right based on this. But you can do even better. That second calc. Now, I'm showing you this, and you can use this, but you're not going to get full credit if this is all you use. Which one of those words seemed like a good plan for this particular question? Intersect. Second calc, intersect. And then it will walk you through what it's asking for. First curve. Like, yes, I want the parabola to be the first curve. Second curve, yes, y equals 45 is my second curve. And then guess, so you can pick where you want to guess. Obviously, there's 2 answers. I guess we can get that one first. And now I've got a better answer. I still wouldn't say that's an exact answer because it's only accurate to whatever 8 decimals, but it's certainly accurate 3.090. So I used my calculator to get there. Again, if that's all you do, you're not going to get full credit, but it's a great check. Check the other one, second calc intersect, first curve, second curve. I'm pretty sure this one's going to be right if the first one was right. 0.910. So second calc intersect. Now that's not showing your work algebraically, but it's using your calculator to verify that you got the problem right. And so that's completely okay to. If I say you have your calculator, then that unlocks all of the calculator can do. So use it, but I still want to see the algebra that gives the algebra answer. It's also why frequently we ask for the exact answer, because the calculator can't give you the exact answer. It can give you these, but it can't ever give you that. All right, reasonable domain and range. Domain is usually the x values, but for this particular problem, that's the t values. So what makes sense for a domain for this problem? What are the x values that it would make sense to look at? 0 to 4. Because prior to 0, nothing has happened yet, even though there's a graph there. After 4, we've hit the ground. So again, the calculator doesn't know that this is a word problem and know where to stop. It just keeps going, but we know that we're stopping at 4. Range of the y values, in this case it's the h's. It starts at 0, and we already said it went up to, looking up the rest of the page, 64. All right, let's do part of number 2 together, because there's some new, not new words, but new applications of words, I guess. Number 2, a soccer ball is kicked from the ground with an initial velocity of 96 feet per second. Remember, I don't know that you remember this, but we're giving it to you. H of t is negative 16t squared plus v0t plus h0. Well, I don't know if we've talked about this. What does v0 mean? Velocity is like half, right? What's the 0 on the v mean? Initial velocity. So my starting velocity, the time equals 0 velocity. Which means, what do you think h0 represents? Initial height. Okay. When will the ball hit the ground? Let's back up a second. Let's rewrite this equation with stuff we know in there. Negative 16t squared plus v0. What's v0? 96, because my initial velocity is 96. So plus 96t plus, what's my initial height? How do you know it's 0? Yeah, from the ground, sort of code language for h equals 0. So there's my equation. So on the last problem, it just gave you the equation. Here, it sort of gave you the equation, but you had to put in some pieces there. Now, when will the ball hit the ground? Well, that would be where h is 0, and maximum height, that would be the vertex. In fact, it doesn't even ask for you to graph it. So you can use the calculator, but you don't have to graph it. You certainly may graph it. Up to you. Okay, so your job then is to try 2 and 3. Tomorrow, Ms. Craig will answer questions from 2 and 3, and then she'll talk about number 4.